Okay, we're going to record these ball toss directions real quick, just in case. It might come in handy. I shouldn't have frozen the screen. All right, here we go. Okay, make sure you list your materials, but that's pretty much a good list. Don't really need to do that. Oh, and I need the next slide instead of that. Okay, we already did that. We did that. We hooked things up. Okay, so this year, oh, I don't want that. It's been malfunctioning. Thanks to our whole situation this year, I'm really getting away from printing graphs. If you just love that and you know you're going to print the rest of your report on paper and hand it to me, that's okay to do that. Okay, but what we really need to do is identify these different regions. Okay, and people seem to, when it says label and identify and all this stuff, people seem to kind of panic. What do we do? It's a PNG. I don't want to edit that. I don't have software. That's okay. Totally fine. I have a trick. Okay, by the way, this is data person's job. And it's actually pretty easy. You're going to take the best graph that that calculation person gives you and copy and paste it into a page. And it should take up about half the page. Okay, so it's going to look like, probably even nicer than mine. It's going to look like that. Okay, and you could do, I did side by side here for my convenience showing this. You could do, the graph could be the top of the page, and the and your explanation that's coming up here could be the bottom. Okay. By the way, so we are going to mark specific points. They're points in what? I'm plotting position up at the top, and velocity and acceleration versus what? Versus time. So the points that I'm going to mark are just points in time. Okay. So actually, once you have this picture pasted in, and you have your time axis clearly visible, it's really easy to say what point we're after. Okay. For example, like right here. Oh, I wanted a different color. Come on. Yes. Okay. So the data person says, like, here's my point. That's the top. You can organize this however you want. Where time equals 3.4 seconds. You can have this next to or below. There, that's where I'll have Vy equals 0, y equals y max, the top. And this is important to do because you are actually, when this graph is sloping up, you're actually on the way down. And when it's curving up like that, because the whole graph is inverted, this is the up section. Okay, so when I say mark or label the points, just tell me what time frame you're at, and maybe which graph you're on. Like there's y, here's v when it's there. Yeah, okay, it did it. You're at the top, the same point in time where you're crossing the axis. Wow, that's interesting. It's right there. Your acceleration is constant. It's got cool accelerations. Okay. Any questions? So most of data person's job is to take your one prettiest graph and label that stuff by telling me at what time and on which graph. It could be position, velocity, acceleration. It could be top, middle, bottom. Which graph at what time is showing what you're talking about. And so you can just do a nice big list of all that stuff. Okay. Okay. Your whole conclusion for this graph, we are not going into super duper statistics. You're only in like pre-calc or so, or maybe algebra 2 honors, right, this year. This is not the calculus year, and nobody's in AP stats, right? Anybody? Okay. It's a little early. All right. So we are just going to use our accepted value of g equals 9.80. I wonder why that's so laggy. Meters per second squared. If you're the calculation person, aside from running the computer, you just have to show your percent difference at each step. Yeah, really easy. You might, if you're really showing off, you could show me one time, even though I'm an Algebra 1 teacher, how to do the percent difference. Okay, but that's it. You're going to get, so if I flip back a couple things, you're going to get your value. Oh, you have to multiply this one by 2. So it would be 9.62, okay, is a little bit less. So I should have a negative percent difference. Oh no, you have to watch for negative signs. So you would take 9.62 minus 9.80, divide the total by 9.80, and make it a percent, okay? So if you're the calculation person, you're just doing that for a bunch of stuff. However, if your group is ambitious and you want to do the the extensions have some more analysis, some more math for you to do, okay? Also not too terribly bad. Okay, and then the conclusion is conclusion. So it's really, if all you're doing is the straight up report to get 25 points, it's really not bad at all. Each section is really very short. You don't have to repeat my whole method. Tell me, list the materials. I followed Whitcomb's directions, maybe with a few exceptions or adjustments, or had to restart stuff. Yes, sir. I really want it negative because coming up here, let me explain these extensions. It really does matter whether the percent difference is negative or positive. Okay, different things will cause that. And if you're choosing to do the extensions and really get the bonus points, then you're about to find out why that's important. Okay, I know there are a bunch of these things, and if you do an awesome job with pictures or GIFs, you could get bonus points that way, but I'm going to cap it at 2.5 points maximum, which is plus 10%. That's just this report. Probably doing all the extra credit in labs will get you 5% lab points over the top, which is just an extra 1% in the class, because it's lab's 20%. So that's not that fantastic. It sounds great now, but you might really be happy to have that 1 more percent than you could otherwise get. Okay, you need to, if you're doing extension 1 properly done, that's plus 1 whole point. Okay, but it means you have to have 6 slopes. So you have to get at least 6 bounces, 6 different slopes from 6 different bounces. Possible to do it in all in one file, but maybe not. That person, now your data person, if you're doing this, your calculator, excuse me, your calculation person has to use a spreadsheet like a Google Doc, a Google Sheet, or Excel, and do the standard deviation. Why won't it draw? Which with 6 points is really easy. The function is probably called stdev, standard deviation. And I would just do a little, for the report, I would then just do another little snip or screenshot of your table from the spreadsheet with the standard deviation calculated to show how you got that. Okay? By doing it 5 times, you are now calculating with an average and standard deviation. You won't get, if you just give me 6 slopes and the average, which I can calculate in my head, I'll give you half a point extra. If you have to do the standard deviation and tell me, you have to explain what that means, and so I'm telling you now and recording it. What that means is if you do the experiment 6 times, you're checking for how much it changes with the same equipment and the same machines, how much it changes time to time. So that explains, like if you're off only 1% from G, but these can vary like 2% every time, well, it's probably just by accident. And maybe, and maybe this, so we really should get 9.80, but maybe just that one time that we chose to check carefully, it was off by a little bit at random. On the other hand, if your standard deviation is super small and all 6 slopes are like exactly the same, but they're off from 9.8, that tells you, oh, there's actually something wrong with the experiment itself. Maybe we're not accounting for air resistance properly or at all or something. That tells you that your experiment is awesome and there's a flaw in the design. Okay. Do you have a question? Correct. It can be 2 files with 3 bounces each. Sure. It can all be done in one file, and you just measure on each bounce. You have it compute the different slopes. That's okay. It's the same equipment, same situation. I just want different slopes. Watch, most groups will get some change in the slope just because it's not perfect. And so you're by doing that 6 times, and getting standard deviation and average, you're measuring that. Okay. You are. Oh, I better show this. Did I insert a picture like I wanted? For number 2, for extension 2, to really understand the effect of air resistance, you're going to take these brackets and move them like this. You're going to do one bracket that's just the first half and one that's the second half. Okay, because here we are on the way up. How should air resistance affect the ball on the way up? Air resistance opposes motion, so when the ball moves up through the air should be pushing down, the same as gravity. So your G should actually be a little bit more on the upward bounce. And then your G should actually be a little bit less on the downward bounce if air resistance is a factor. And so if you analyze the different halves of the graph for extension 2, that can tell you that. On the other hand, if maybe you picked the heavy, awesome lacrosse balls and they get exactly the same acceleration up and down, then air resistance is not a factor for that ball, but you just tested it. So you learn a little bit more with each extension you do, okay, especially the first two. Okay, if you saved your file in a place where you can get it and reopen it, you can just go in for extension 2 and draw the two brackets like that. Just scooch one over, take the one, move it over to the center, draw another box, and analyze the other half. Done. You got to do all three for extension 2 so I can compare side by side. Any questions? Okay. So some people really dislike Mr. Pugh downstairs, wanted to use that awesome lacrosse ball the whole time. That's okay. I okayed it. If you did, though, if you have done lacrosse up to now, that is the more dense ball. So switch to racket. Switch to the racquetball for 4 and 5. So you've done the dense ball. Just note that for extension 4, and switch to the racquetball. Okay. Last year I was really on their case. I didn't trust them not to break the equipment. I'm just more relaxed now with equipment anyway, because we're getting new equipment soon. Anyway, or next year or two. Sorry. So I forced them to use the racquetball. You're just comparing the balls of the different densities to see if maybe you can tell with just the whole run, will air resistance be a factor? It should definitely be a factor with, you can use a balloon instead of a beach ball, or there's coffee filters back there that will, what happens is it will really quickly reach its terminal velocity. And then you must use the racquetball for number 5 in case it does land on the detector. They're light enough that it's okay. I don't know. Okay. Just say R also. Okay, any questions? Okay, fantastic. Then you have the rest of the